Okay guys, so now we are going to see with respect to the classification of your crystalline solids. Basically, your crystalline solids have been classified into majorly four portions. First one is called as that of your molecular solids. Okay. Second one, it is called as that of your ionic solids. Third one, it is called as your metallic solids. And the fourth one is called as that of your covalent or network solids. This molecular solids is further classified into three types, called as that of your non-polar molecular solids, polar molecular solids, and that of your hydrogen bonded molecular solids. So in all these classification, we are mainly putting focus with respect to the categories under what are the constituents in all these solids. First part, what are their conducting capacity, whether they are good conductors or bad conductors of electricity. The next most important thing, we are going to see that what type of force exists between these molecules or atoms. And the last one, we have to see that what will be their examples. So these are the major important four categories. We are going to see that what, depending upon these four parts, how your solids have been classified. So coming with respect to that of your molecular solids, remember your molecular solids means here the constituents are your molecules. In the name itself it is mentioned. So here the constituents, particles, whatever the solids contain in the molecular solids is basically your molecules. So coming with respect to its further classification, we are having a non-polar solid. Remember, in non-polar solid, what is happening means here also you have the constant. In all these cases, we are having a molecule itself. Okay. In non-polar solids, mainly what type of a force exists is very much important. So one molecule is holding another molecule by a London forces, which is very much weakest force in nature. London force. In bonding, London force is assumed to be one of the weakest force. So such type of a force which exists between the two molecules will be classified as that of your non-polar solids. And basically they are very smooth and also a bad conductor of electricity. Examples you can give that of your noble gases like your helium, argon, and even your molecules like your chlorine, hydrogen, remember, in the solid state. So those are called as what? As that of your non-polar solids. Coming with respect to that of your polar solids, very much important, here we have to mention that polar means what? Of course, there is some sort of a charge separation within a molecule. That is, if I consider this one as a one polar solid, of course it is not an ionic solid, but there will be some charge separation, plus and a minus. Both they are existing, that is why they are of neutral. But what is happening? Certain charge separation is there. In one end your positive charge is concentrated, in another end your negative charge is concentrated. So what type of the force exists between these solids means it is called as with respect to dipole-dipole interaction. That is, if I can say this one has a one molecule and another molecule will be attached to it in this way. So whatever the forces existing between these molecules, that is called as what? As dipole. Dipole means two poles. Dipole-dipole interactions. Dipole-dipole interactions. So such type of a force which exists between these solids are categorized as that of your polar solids. Remember, they are also very smooth and also bad conductor of electricity. Coming with respect to that of your hydrogen bonded molecular solids, of course by the name itself you are going to get that what type of a bonding exists. Of course, it's your hydrogen bond. So in a hydrogen bonded molecular solids, we could see that, of course, your one atom will be your hydrogen itself, which will be bonded with some other atoms, which may be your fluorine, your oxygen, your nitrogen, any one of it. So these type of solids, whenever you seeing, they are classified as that of your hydrogen solids. One of the greatest example we can just see as that of your solid water, which is nothing but of your ice. Bonding which exists between that of your oxygen and hydrogen part. Here also they are also very volatile liquids or very soft solids at nearly at a room temperature and the pressure. Coming with respect to that of your conductors, they are also non-conductors of electricity. So these are classified as that of your molecular solids. Coming with respect to the ionic solids, of course, by the ionic solids, the name itself is indicating what will be its constituent particles. It will be your cations and anions. So whenever an ions are present, of course, we know that what type of a force exists between them, that is called as that of your, yes, electrostatic forces or a Coulombic forces, which is holding these constituent particles together. So such type of solids are categorized with respect to that of your ionic solids. Of course, when you are saying with respect to its electrical conductivity, what you can say, in solid state they cannot conduct electricity, because what has happened over there, the ions are very closely held together. We are not able to move. They are not able to move to carry the charge. Alva. But what happens in the molten state? Of course, for example, if I take as an NaCl in the solid, it is a bad conductor of electricity, or it cannot conduct. But when it is dissolved in water, what happens? You'll be getting as Na plus and Cl minus, and individual ions will be obtained, and they will be responsible for the carrier of your current. So in the molten state, they are acting as a good conductor of electricity because of their individual free ions existence. So these type of solids are categorized as that of your ionic solids. Of course, they are having a good conductors of electricity in the molten state, and they have very high melting point and also as that of your very high boiling point. Coming with respect to that of your metallic solids, of course you can only say that. So in these solids we can just see the bounding of your metals, and remember they are bounded with respect to that of your free electrons. Yeah. So if I consider that of your metals, they are mainly bounded with respect to some free electrons which is existing. So whenever free electrons is existing within a system, what you can say with respect to their electrical conductivity or that of your thermal conductivity? Recall, as we know that if we are an electrical energy or electrical conductivity path should be there, means there should be some carriers. In ionic solids we saw that in solid they were completely hold together, so it was bad conductor. But in molten state, as soon as they got as an individual ions, these ions were responsible to carry the current. But in metallic solids, what is happening? There is certain charge carriage which is called as that of your free electrons or the mobile electrons. And due to this presence of the free electrons or mobile electrons, what happens? They will be acting as a electrical carriers. And that is the reason we'll be saying that metallic solids are the good conductors of your electricity and also that of your thermal conductivity. Coming with respect to that of your covalent solids or network solids, of course here is that of the bonding between the molecules is that of your covalent bond. Coming with respect to its conductivity nature, they are very bad conductors of that of your, or we can say they are very non-conductors. They are non-conductors of your electricity. Just I would like to mention that in metallic solids, of course, there has been used a word as lustrous. Lustrous means nothing, it means shining. Of course, when you are seeing the metal, it will be very shining, like that of your gold, your copper, they are shining. And this shining property is also coming with respect to that of your free electrons itself. Of course, metallic solids are your malleable and ductile. But coming with respect to that of your covalent solids, of course, as I mentioned, they are non-conductors of electricity and they are very hard and brittle due to the presence of the very strong covalent bond between the constituent particles. So these are the ways, by seeing certain properties, you are classifying the crystalline solids as molecular solids, in which the constituent particles are your molecules. In ionic solids, in which the constituent particles are that of your anion and cation. In metallic solids, the constituent particles are that of your metal atoms, which are bounded by that of your free electrons, remember. In covalent, here also they are the atoms which are bounded with respect to that of your strong covalent bond. So this gives us the major classification of that of your crystalline solids. So this was a certain basic thing one has to know when you are dealing with this chapter. So in the this class we will be dealing with one of the most important aspect, that how these solids are arranged. So whenever you have been given with a crystal, in a crystal how these atoms are arranged. Okay, so let's see in our later version of how these molecules or atoms are arranged in a crystal.